Hi, and thanks for joining. Today's topic will be decision making, and ultimately, better decision making. Since decisions can only be as good as the data they rely on, we're going to explore what good security data looks like and how it can help you make better decisions. I'm Shani, and I'm a director of product here at Snyk. I've been with Snyk for a little over a year, but I've been in the security domain for well over a decade. I'll walk you through different levels one can expect from vulnerability databases. With me today is Parag from Red Hat, who leads the SaaS and AI solutions for Red Hat developer tools. After I explain why good data is so important, Parag will talk about the Red Hat use case and experience. So we'll start with something very basic and intuitive, not even related to security. Markers. Let's say I want to buy washable markers, and I came across this option. They look great. I wonder if they are really as sweet as stinky as I'm hoping they are. We all know what to do next. We simply look at the reviews. I see they got a 4.6 rating. That's really good. Easy decision to buy them. That's it. As simple as that. The same can apply for vulnerabilities. Let's apply the example to our world of open source. I want to use this package. I've looked into everything, and it seems like this is what I need. I just want to make sure it doesn't have any vulnerabilities before I go ahead and use it. I'll use any security tool and scan for vulnerabilities. I found there's only one, a low severity one. So I decide I can go ahead and use this package safely. That's it. As simple as that. Was this bad decision making? I call this decision making level 1. It's simple and fast. It's a sanity check. And it's great for buying washable markers. It can also be great for software, just not any software. It really depends on what's the software's role. Level 1 decision making is about having a vulnerability database. Now, let's take it up a notch. Say I want to buy a trampoline. I came across this one, and it looks great. The first thing I do, just as I did with the washable markers, is to look at the reviews. Look, it has the exact same score as those markers, 4.6. That's a really good score. I should be happy. But suddenly, that's just not enough for me. As the price is high, it takes up a lot of room, and it has a safety component. I now have a higher standard to meet. I'm starting to ask questions such as, are 461 global ratings enough to make me trust this 4.6 score? Are the 5-star ratings accurate? Are there disappointed buyers who didn't rate and I have incomplete information? Is the information updated? I need some trustworthy ratings. Now, let's go back to our package and our scanning solution. Can I trust this result? Maybe there's another vulnerability, this time a high severity one, that the vulnerability database just didn't have. No, that's quite common, as some vulnerability databases only support CVE vulnerabilities and wait until those are published on NVD. From our observations, it might take NVD an average of over 100 days to add a vulnerability. You shouldn't wait so long. You need a solution that adds vulnerabilities quickly and isn't blocked by NVD space. Maybe even the low severity, it's not accurate, and it's actually a 6.4, not a 2. Not all vulnerability databases verify the CVSS vector and score. Maybe even the entire vulnerability is a false positive because the vulnerability database got the package name or the version wrong. I just want to know what severities exist here so I can make my decision. That's it. Is that too much to ask? To support your decision making, you want to know all the vulnerabilities that exist, complete data. You want to make sure you always have the most updated information. That's timely data. And you want to make sure you have the right data. No false positives of any kind. Accurate data. If level 1 decision-making was about just having a vulnerability database, level 2 is about having a trustworthy one. Now we can make better decisions, decide whether we use our package, and buy our trampoline. This is all really great. Until you buy a car, or a laptop, or a house. Do you really imagine buying one of those just based on the fact it was given 5 stars? Back to our package. Now, say it's not about what package to use. You're already using this package in this version, and you found this high vulnerability. You now need to decide if you're going to spend your time fixing this issue. Would you go ahead and fix it just based on this? There are just some decisions that can't be based on a simple score, which means it's time we talk about advanced decision making. Now, you can't go advanced if you don't have the basics. So our vulnerability database is already complete, timely, and accurate. This goes without saying. So what are we really talking about? What additional information might be useful here? First, let's see what we're dealing with. It's nice to start by looking at the CWE, that's common weakness enumeration. In this case, it's easy to see the problem is that we have some hard-coded credentials. This might be okay, and it might be really bad. That depends on the context. We'll leave the talk about bad practices for another day. Now, after this initial screening, it's time to dig deeper. Some hand-curated text is a good way to learn more and let you know what you're dealing with. Although some of us prefer code, not words. Always best to have as much information as possible so you can find what you need. On the left is the entire advisory in Snyk. On the right, I zoomed in on a few sections. The CVSS vector can also be interesting. Do you know there are high vulnerabilities that require physical access? That might not concern you as others. Which brings us to another question. Have you ever tried to exploit a vulnerability? Trust me, that's not always very easy. It requires a lot of knowledge, especially if you're starting from scratch. On the other hand, it's a whole different story if you can use Metasploit to do that, or even just copy-paste some code from exploit-db. That's the concept of exploit maturity. By looking at exploits that were published in the wild and looking how ready to use they are, as well as other information, we can better assess the easiness of the exploitability. How about this? Back in those days, even if you had other critical exploitable vulnerabilities waiting for you to fix them, I'm sure you would have started here, fixing the OpenSSL security bug known as Heartbleed. This was the vulnerability everyone was trying to exploit, and that's also important to take into consideration. We don't need Twitter to tell us about the next Heartbleed, but there are more subtle cases of vulnerabilities that are now trending in Twitter and in general. Our research shows a correlation between certain trending patterns and an increased risk demonstrated by a higher chance of this vulnerability being exploited for real. That's an important factor to consider when making a decision on the urgency of a fix. So we've discussed CWEs, descriptions, CVSS vectors, exploit maturity, and Twitter trends. Now it's time to go back to the basics and reevaluate what we know about accuracy. This one gets a little technical, so bear with me. Say we have an app that uses a package named Express. That package brings with it additional dependencies. And say one of those indirect dependencies is vulnerable. Normally, we'd say the application is vulnerable too. But what if the vulnerable method is never called? Let's look at what's happening here. Fresh, the package on the right, has lots of methods, just one of them vulnerable. That method isn't being used by the send package, the package in the middle. So the vulnerability can't be reached, not by the indirect package, and thus not by our application. The vulnerability isn't reachable. If your vulnerability database is aware not only of vulnerable packages, but also vulnerable methods, your scanning solution will be able to help you avoid fixing irrelevant vulnerabilities. Let's look at this for a second. Isn't this a nice before and after? Such better accuracy. And while we're back to looking at the basics, let's evaluate severity as well. Last technical explanation, I promise. Let's look at two high severity, 7.8 score C vulnerabilities that exist in a package within Red Hat. They both look similar with the same score. Now, we've just seen how much more information we can gather instead of just looking at the CVSS score. And we're not the only ones. That's what most Linux distributions do. They triage the vulnerabilities and decide how they impact their specific use case. Now, let's have another look at these two vulnerabilities. On the left, you can see Red Hat clearly states they have a different impact. Even though these two vulnerabilities have the same NVD score, 7.8, their impact on Red Hat is dramatically different. One is considered to be low, while the other is critical. Impact is the scoring system Red Hat uses. Ubuntu calls it priority, with a slight different meaning. There's also urgency by Debian, and others too. That's really useful information one might use on top of the regular severity. In Snyk, we call this relative importance, and we make sure this data is available to our users. What else might be useful? We can look at when the vulnerability was added or when the exploit was added. If the vulnerability is malicious, for example, that's definitely something to consider when prioritizing. Also, the versions that are impacted by this. If there's a fix, what's the fix? And many more. There's a lot of useful information. So let's recap. We've started with level 1, which was mainly about the importance of just having a vulnerability database. We then explored level 2, trustworthy databases, mainly talking about completeness, timeliness, and accuracy. And we finished with discussing advanced vulnerability databases, talking about CWEs, descriptions, CVSS vectors, exploit maturity, Twitter trends, reachability, relative importance, dates, maliciousness, fixability, and versions. Wow, that's a lot. Time to sum that up into something that's easier to remember. If you need your code to be secure, but can't afford to fix every single vulnerability, you need to make decisions. Smart, advanced, multi-factor decisions. And as your company grows, you need to take smart decisions at scale. Your decisions will only be as good as the data they rely on. So here's a good vulnerability database. And with that thought, I'd like to reintroduce Parag from Red Hat, who will take it from here. Thanks.
Thanks, Shani. Appreciate your having me join your session. You're spot on. Your decisions will only be as good as the data that drives them. Hi, everyone. I'm Parag. I'm a member of the Red Hat Developer Tools Product Management team. So let's dive a little bit deeper into what's the security focus in the Red Hat Developer Tools portfolio. So as we know, like DevSecOps is a practice that should be a part of the entire software supply chain and not just something that's implemented as a final gate for product releases. So our goal is to help developers address vulnerabilities in their applications while creating code. This means that we have to make it easy for developers to find the vulnerabilities, provide details about the vulnerabilities so they can decide the kind of remediation that needs to be done, and then also provide an easy way to remediate the vulnerability that has been found. Now, when we look at securing applications for developers, in just 10 years, open source has radically changed the way applications get created, right? More than 70% of an application's code base is actually inherited from its open source dependencies. Vulnerabilities can thus arise from not just the code that a developer is creating, but from the dependencies that the application inherits. On average, it was found that it takes more than 2 months for developers to actually recognize and remedy the vulnerabilities in their applications, and especially the ones which are coming in from their open source dependencies. Now, this is hard to see when most, if not all, vulnerable open source dependencies already have a fix that's been published. So Red Hat Code Ready Dependency Analytics, that's our hosted solution that runs on top of Red Hat OpenShift, and that aligns with our mission to help developers find and remedy vulnerabilities in their applications from the open source dependencies. It analyzes the application's dependencies, takes a look at all the vulnerabilities which are in the versions or the way that they have been declared in the application manifest files, like your POM XML for Java or requirements text for Python, or package.json for Node. Once it analyzes these dependencies for vulnerabilities, it also looks at things around license compliance issues. Maybe the license that you declare for your application doesn't really match up with the dependencies that you have inherited in your application. So it looks into that to make sure that you're going to be in compliance. And then it also looks at some interesting statistics about the packages, things like adoption numbers or popularity or maintenance numbers, Just to kind of give you an idea about the quality of the open source dependency that has been added into the application. Now, developers are able to run and analyze their application, so they can run this analysis, view the details of the analysis. They can do all of that directly from the IDE. And so you don't have to leave your IDE to not only analyze the application for vulnerabilities, but also to fix them. You can just do it directly from the IDE. Currently, we support Java, Node, and Python with our solution. Golang's coming up pretty soon, but that's the current infrastructure that we have. And to actually use this extension, you just plug it into your IDE. Just install it as an extension. If you have VS Code, if you have IntelliJ, get it from the JetBrains Marketplace. If you have code-ready workspaces, Eclipse Share, you can grab it from the plugin registry. So it is available as an extension that can just go right into your IDE and enable you to then analyze and fix your dependencies. Now, in order to provide a high-quality analysis and guidance for the remediation paths, we needed a vulnerability database that would list the highest number of vulnerabilities across the board, provide enough information to help with the decision-making process for a developer. It would cover a wide range of programming languages, so we can offer this capability for a major ecosystems. It should be able to catch vulnerabilities in packages as early as possible and provide ways to easily integrate with all this information, the vulnerability data, the details about each vulnerability, the remediation paths. It should allow us to integrate very easily into all this information so that we can then take it, bring it into our hosted solution, and then offer it to all the developers that are using our IDE extension. So these were kind of the requirements that drove what kind of vulnerability database we need for a Red Hat code-ready dependency analytics. When we looked at our initial offering, we were basing it on one of the best CVE databases that's out there, which is the National Vulnerability Database. But we decided that it is better for us to upgrade to Snyk's Intel, the Snyk Intel. So before we partnered with Snyk, because we were leveraging the CVE information, it was a great source of information. But Snyk's database gave us a much richer and a broader information about vulnerabilities and their details, right? So Snyk Intel includes vulnerabilities that are known only to Snyk. And Snyk takes really hard care in curating these vulnerabilities. So these are vulnerabilities that Snyk actually discusses with the open source developers that own the packages, making sure the vulnerabilities. And so there's a lot of background work that goes in, as Shani had mentioned in her presentation, before the vulnerability makes it into the database. So that broader set of vulnerabilities for us was invaluable, because now we can actually let the developers know about vulnerabilities which are not in the NVD. So number one, we were able to get a lot of broader amount of vulnerabilities which are known only to Snyk. The information about each vulnerability was very crucial, right? Well, there's some good pieces of data there. We have information about what kind of exploits are available for each vulnerability. Is it really mature, or is it like kind of in an undefined state where there are no known exploits, so which means that the intensity of exploiting that is going to be lower, right? Also information like which version of the package fixed the vulnerability. So what's a fix in a particular version, then we can find that out in the Snyk database. We also saw that it is very timely in reporting vulnerabilities, so it reports them as soon as possible. And the data model of the database and bringing it into our hosted solution is actually pretty easy to ingest. So these capabilities of the database itself, the characteristics of the data itself, and the ease of integration made it possible for us to, in a very short time, upgrade our backend vulnerability database from NVD to Snyk Intel. The other part of that is because the information that it includes included along with the vulnerabilities is about the details about the vulnerability. Developers who are in our IDE extension will also get access to specific details about each vulnerability with a click directly from the IDE. So now this is free, right? So there's all free access for developers. So they can learn about, hey, what kind of vulnerability it is. They can even look at the history of vulnerabilities across all the different versions of a specific open source dependency. This makes it much easier for developers to determine if they need to remediate the vulnerability now or a little bit later or never. In addition, if you look at the exploits information that we talked about, now this information is curated by Snyk and it's considered as what you can say premium information, right? In order to get additional details about this vulnerability, like exploit maturity, being able to automatically get a scan of the Git repo where the source is, through Snyk's backend processing, and able to generate PRs to kind of fix them. All you have to do is just have a free registration with Snyk. And once you register the free account, Snyk provides a token, and that token can then be saved in the Red Hat Code Ready Dependency Analytics. This capability that was designed with Snyk and Red Hat together makes it much easier for developers to not only get free access to all the different information that Snyk provides, but also to get access to all the premium information that is provided by Snyk by just putting in the token. And we can do all of that from our ID extension. So that kind of a collaboration and a partnership model was really fruitful for our developer community. That we are seeing that. And so this information, which is very rich, is now automatically available in the Red Hat Code Ready Dependency extension. So this was a big plus for us to kind of bringing in the whole seamless experience for the developer directly from the extension. So in summary, by integrating with Snyk Intel, Red Hat Code Ready Dependency Analytics was able to provide now a higher quality vulnerability analysis, much better information to help developers decide on the remediation paths that they need to follow. And the entire user experience of the data and the vulnerability and the analysis and any additional details is all seamless now. It's integrated across the ID extension, the Snyk's data pages, the web pages, it all comes into one place. And best of all, it's freely available for every developer. So we are very happy of our decision to upgrade from into the Snyk Intel database, and we're looking forward to our partnership together with Snyk. So thank you for joining our session. I hope you found it valuable. I'll take a look at the questions you may have asked during the presentation, but if not, please feel free to reach out to me directly at my Red Hat email address, which is pdave@redhat.com. Thank you.